Number 1, what is 20% of 440? Percents are one of those things that you can do multiple ways. When you are doing this with a calculator, you're going to be multiplying when you're saying what is this percent of a number. So we would be multiplying 440 by 20%, and 20% written as a decimal is 0.2 or 0.20. So if you're wanting to use your calculator, you can, and that's what you would put in to get your answer. Now, another way you can look at this, if you're wanting to do this more, in your head, which I'm an in your head kind of person. I like it. I know I'm strange. So I would say 20% of 440. Well, 20%, because it's 20% out of 100%, 20% is the same as 1/5. If we simplified 20 over 100, we would get 1/5. So I'd say, okay, what's 1/5 of 440? So I could divide 440 by 5. You can do that too. And yet a third way you can do it, just throwing all these ways out at you, is you can say 20% is like 10% times 2. Like 10% times 2. It is 10% times 2. So what is 10% of 440? To take 10% of anything, you just move the decimal place over one spot. So that would be 44. And then you just multiply by 2. 44 times 2 is 88. All of these methods will give you 88. Use the one that is the most comfortable for you and the one that you can accomplish the fastest. If you're very comfortable with this sort of mental math, for me, I would use that method. Get rid of that, select again for more options. I don't know why that's refusing to disappear. There we go. This, for me, would be the fastest. For others, doing it on the calculator would be the fastest. Know yourself, know where your strengths lie, and then you can save the most time on the SAT. Number 2, argon is placed inside a container with a constant volume. So a sealed container. This would be like it could be like a cylinder or a cube or something, but it is a sealed container. It is enclosed. The graph shows the estimated pressure Y in pounds per square inch psi of the argon when its temperature is X kelvins. Okay, what is the estimated pressure of the argon in psi when the temperature is 600 kelvins? Okay, so they don't want us to calculate anything. They want us to be able to read this graph, this chart. So let's see what they're saying. What is the estimated pressure? And we were told pressure is our y-axis. So that's going to be, pressure is over here. What is the estimated pressure when the temperature is 600? And temperature is down here. So we're going to look for 600, and then we're going to follow it up. And we go, here is where that line, that graph is. Let's follow it over to the side. And it shows there, the graph shows that the pressure at 600 kelvins would be 12. So my answer here is B, 12. Number 3, the function f is defined by f of x equals 4x minus 3. What is the value of f of 10? Anytime we have a function, like in this case, so it's f of x, no matter what it is, if it's f of x equals blah, 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 whatever is on this side, if they then ask what is f of 10, f of 25, f of a million, in this case f of 10, what they are saying is they want you to take that 10 and plug it into the equation wherever you see an x. That's what that means. That's how you solve these. So let's take the equation they gave us, which is f of x equals 4x minus 3. And they say, what is f of 10? We're going to plug 10 in wherever there's an x. There's only one x in this particular function, but we're going to plug a 10 in there. So 4 times 10 would be 40, and then we want to subtract that 3. 40 minus 3 is 37, so f of 10 for this function is 37, and that is B. My answer is B. Number 4. Which expression is equivalent to 16x cubed y squared plus 14xy? And then we have all of these options down here. Now, if you are very comfortable with factoring and pulling out a greatest common factor, you might jump straight to looking at the greatest common factor for that. And that's the first way I'm going to show you. So 16x cubed y squared plus 14xy. When you're pulling out a greatest common factor, you want to look first at the numbers and then at each individual variable in turn. So first our numbers are 16 and 14. They're both even, so I immediately think, okay, 2 goes into both of those. What happens if I pull out a 2? 2 times 8 is 16, 2 times 7 is 14. Are there any factors bigger than that? No, because there isn't any number that goes into 8 and 7 into both of those. So I've got it. 2 is my greatest common factor for 16 and for 14. Now I'm going to look at the x's. I have x cubed and x. When you're pulling out a variable, it's always going to be the smaller of them. So I have an x cubed and an x. X is smaller, has the smaller exponent, so that's what I pull out. It's always, 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 always. So I pull out the x, and that leaves an x squared, because I'm going to subtract 1x from that, so there's an x squared. And on this one, I pulled out an x, so there's no x left. I don't write anything down here. I just don't. Now onto my y's. A y squared and a y. The smaller exponent there is the y, so I pull out a single y. Y squared, there were 2 y's. I took 1 away. Now there's only 1 y left. And over here, there was only 1 y, and I took it out, so there's nothing left. The sign doesn't change because I didn't pull out a negative. I pulled out a positive. If I had pulled out a negative, the signs here would have changed, but I didn't. And I'm done. I pulled out the greatest common factor of the number and of each variable in turn. So 2xy times 8x squared y plus 7, and we can see that is here, that is b. If you are having, if you have difficulties with the greatest common factor, one thing you can do is start by looking at their answers if it is a multiple choice question. And if it's something like this where it's saying factor and you've got these x's and y's, it's going to be multiple choice because you can't input that into a student generated response question. The only one I can think of is if they asked you what is the greatest common factor of 14 and 16, that would be a number. But this kind of thing, it's going to be multiple choice. So it is one where if you're having problems remembering this or how to do greatest common factor, I would suggest looking over here at the answers. And as you can see, if you zoom in here and just look at them really closely, there are only 2 options for the greatest common factor, 2xy and 14xy. So, there you go. If you can get it narrowed down to either one of those 2, you've got now a 50-50 shot. And also you're like, which of these, if I multiply it back, would get me to that? That's another way to look at it. All of these sort of strategies are helpful, especially if you're having, a moment where you don't remember a concept. Always look at the multiple choice answers. They can be a huge, huge help. But again, just lastly, that answer there was B. Number 5, a veterinarian recommends that each day a certain rabbit should eat 25 calories per pound of the rabbit's weight, plus an additional 11 calories. Which equation represents this situation, where C is the total number of calories the veterinarian recommends the rabbit should eat each day if the rabbit's weight is X pounds? Okay, so first I'm going to show you how to figure this out, just like as if there were no multiple choice options, and then we're going to look at the multiple choice options and see how they can help you. All right. So if I'm just looking at this and say, the rabbit is X pounds, or my variable is X. How many, which equation represents the situation where C is the total number of calories and they want to know that's X pounds? Okay. So what is, anytime you have is, this is where our equation, our equal sign comes in. So when we say what is the total number of calories? So the calories should be equal to what? Well, the rabbit's weight is X pounds. So X is the number of pounds that this rabbit is. And we're told should eat 25 calories per pound plus an additional 11. Well, let's start with the 25. 25 calories per pound. And this can be something where using real numbers can make it more easy to see it. So if it's 25 calories per pound, how many calories is that if the rabbit weighs 1 pound? Well, if it's 25 calories for every pound, I'd say, okay, 1 pound times 25 would be 25. What if it was 2 pounds? Like, okay, 25 calories for each of those pounds, so I need to multiply this by 25. 2 times 25 would be 50. So I'm just making 3 pounds. Well, I would need 25 calories for each of those 3 pounds. 3 pounds times 25 is 75. All right, so I'm just multiplying the number of pounds by 25. Well, in our equation, x represents the number of pounds. So I'm going to take that 25 and I'm going to multiply it by x. But is that what the veterinarian said? Part of it. What else did the veterinarian say? They said plus an additional 11 calories. So plus an additional 11 calories. So that would be my equation. And I've covered everything that the veterinarian said. They said 25 calories per pound plus an additional 11 equals the total number of calories each day. So I'm going to look over at my options, and sure enough, D is there. C equals 25x plus 11. Now, if you were struggling with where to start with this, this is where I would look at these multiple choice, and you'll see all of them are set up as C equals. So you go, okay, well, I know it needs to be C equals something. And then I would say, which of these is most likely? Well, I've got 25 calories and then 11 calories. Well, this only has a 25 in it, so that one's out. And then you go, what have we got left? We got C equals 36x, 11x plus 25, 25x plus 11. Since it's 25 calories per pound and then separately 11, it's not saying 25 and 11 per pound. So B would also be out. And then I would look at these and go like, okay, this one they're adding 25 and this one they're adding 11, and it said plus 11. So it needs to be the one that's plus 11. And sure enough, there's that 25 times the number of pounds of the rabbit. So definitely, if sometimes I know with word problems, those can be very tricky for students in kind of figuring things out. And a lot of times looking at the answers, if you get stumped, can be very helpful and can get you on the right track. So again, it's D, C equals 25x plus 11. Number 6, if 6n equals 12, what is the value of n plus 4? So here we're going to solve for n. What is being done to n? N is being multiplied by 6. 6 times n. To get n by itself, we need to undo what's been done. Division is the opposite of multiplication, so instead of multiplying by 6, to undo that, I'm going to divide by 6. And because it needs to stay balanced, that's what that equal sign means. These two are balanced and the same. I have to do it to both sides. So on the left, I just have that n, and on the right, 12 divided by 6 is 2. So n equals 2. But did they ask that? No, they didn't. And a lot of students fall into this trap where they solve for x or n or whatever variable it is, and they go, I've got my answer, boom, and they move on, and no, you just got it wrong. They didn't ask for n, they asked for n plus 4. So 2 plus 4 is equal to 6, and that is my answer. Number 7. D minus 30 times D plus 30 minus 7 equals negative 7. What is the solution to the given equation? This one may look a little more complicated, but when we look at it a little more closely, this one, whoops, there we go. I think it's easier than you might think. If you remember what you've done in factoring and our sort of standards for how we solve quadratics and factoring, I think this is going to be a really quick one for you. Okay, when we have something that's factored, we have a quadratic, and this is a factored quadratic, this part right here. Like when you have, when you're factoring, x squared minus 2x plus 3, that kind of thing, and you're factoring, and that's not factorable. I just got that wrong. Yeah, that one's not factorable. It would have to be like minus 4x plus 3. That one's factorable. And you get it and you factor it, and it looks something like that. You have those two binomials. So this one, it's already been factored. So that's nice, because when we're solving quadratics, we always factor first. Well, it's already been factored. Okay. But what's going on over here that's different from normal? Well, usually when we're factoring, if we're trying to solve it, usually, always, it has to be equal to 0 for us to solve it. Well, let's see if we can get that equal to 0. We've got a minus 7 over here. It's hanging out. What happens if I get rid of that 7 by doing the opposite? I get rid of it from this side, from this left side. What happens if I get rid of it? Well, the opposite of subtracting 7 is adding 7. So I'm going to add 7 on both sides because we have that equal sign in the middle. So we have to do it to both sides to keep it equal. So on the left, boop, I have that d minus 30 times d plus 30. And on the right, negative 7 plus 7 is 0. Ding, ding, ding. We've got our 0. So now we're in that normal sort of algebra factoring situation where we have two numbers, because these both represent numbers. This is a number minus 30, which would then be a new number, and then a number plus 30, which is a new number. So these two numbers multiplied together equal 0, which means one of them must be 0, one or both. And that's how we solve quadratics, is we go, we factor them, they're getting multiplied together, one or both of them has to equal 0, so we're going to separate them and solve, say, what would it be if d minus 30 is the one that equals 0, and what would it be if d plus 30 is the one that equals 0. So over here on the left, d minus 30, to undo that minus, we're going to add 30 to both sides. Let's zoom out a little bit because I always write too big. I just get d on the left, and on the right, I have 0 plus 30, which is 30. On my other one over here, d plus 30 equals 0. The opposite of adding is subtracting, so I'm going to subtract 30 from both sides. And d plus 30 minus 30 is just d, and 0 minus 30 is minus 30, negative 30. And what did they ask? They said, what is a solution to the given equation? So either of these is okay. You can either put 30 or negative 30, and you will get it right. That's it. Number 8. Line R in the xy plane has a slope of 4 and passes through the point 0, 6. Which equation defines line R? Okay, so if you want to visualize this, we have a line. It passes through the point 0, 6. 1, 2, 3, 4, 5, 6, and it has a slope of 4. Now, I'm not drawing this to scale. I'm just kind of like giving you a little, it's going to be steeper than that, actually, but that's the general idea. Which equation defines line R? Now, if we look at our answers, because we have to look at the answers, right? We have to see what form the line is in. Is it in standard form? Is it in slope-intercept form? And here, all 4 of these are in slope-intercept form. That is, they are in y equals mx plus b, where m and b are constants, and that m represents the slope of the line, and b, represents the y-intercept. And what is the y-intercept? The y-intercept is where the line crosses the y-axis. So if we look at this little sketch of a line, which I'm doing just to help you visualize where it's at, that 0, 6, that one point they gave us, is the y-intercept. When the x value is 0, we're being given the y-intercept. So right here, it's crossing the y-axis at 6. So my y-intercept is 6, positive 6. And what is the slope? Well, we are told that the slope is 4. So 4 goes in for my m. And now I have written an equation of a line. Occasionally, when you get to this point, you might see them pull some shenanigans like multiplying everything or, by a number or putting it in standard form or whatever, but it doesn't look like we've got that this time because they're all y equals, they're all slope-intercept form. So let's look and see, is y equals 4x plus 6 one of our options over here to choose from? And sure enough, it is. It is D. There is my answer. Number 9, a competitive diver dives from a platform into the water. The graph shown gives the height above the water, y, in meters of the diver, x seconds after diving from the platform. What is the best interpretation of the x-intercept of the graph? All right, so we have this drawing, this graph, and it's a little diver person who is on a platform, and they are diving into the water. And this graph is representing how tall, how high they are so many seconds after they leap. Okay, so let's look Let's really look at this. And I'm going to look and try to figure this out before I look at their options. I think that, for me, that works the best. So we're trying to figure out what the x-intercept means on this graph. Okay, so we have height in meters, time in seconds. So at 0 seconds, where is our little diver person? Diver person is up here on the platform. 0 seconds. They have not yet dove. And they're up here at like 10 meters. And then he gets slightly higher because he jumps up. And like 0.2, 0.3 seconds in, he's a little bit higher than the platform. And then as time is progressing, he's diving down, diving down, diving down until about the time of maybe like 1.6, 1.7, because it's a little past 1.5. I'm going to say like 1.6 or 1.7. He's at 0 meters. So he's in the pool. I say he, it could be a she. They are in the pool. It's either. So this person is in the pool. And it's at 0 meters. All right. So there's my interpretation of it, is that this at 0 up here, this point represents before they've dove, before they have dove, before they dove. And then down here, the x-intercept represents when they hit the water at about 1.6 or 1.7 seconds. Okay, so now I'm going to look at their options and see which of these best hits and best lines up with what I've just said. A, the diver reaches a maximum height above the water at 1.6 seconds. No, not at all. Because look here at 1.6 seconds, and I'm going to erase all my crazy scribbles. At 1.6 seconds, maximum height, is that maximum height up here? Nope, that one is out. B, the diver hits the water at 1.6 seconds. Hey, that sounds exactly like what I said. I think that might be our answer, but let's look at the others just to be sure. C, the diver reaches a maximum height above the water at 0.2 seconds. Now here's where they're being tricky. It does look like he reaches a maximum height above the water at about 0.2 seconds. This on its own appears to be a correct statement, but did this ask for which of these is correct? No. It said what is the best interpretation of the x-intercept, that point. That's the only point we're concerned with. And that word best is why I look at all 4 options, because it's the best interpretation. There might be 2 that are possible, but one's better. So, okay, so C is out, even though it is a true statement, because it's not what they asked. They didn't ask for what the interpretation of the maximum of this graph means. They asked for the x-intercept. That one's out. And D, the diver hits the water at 0.2 seconds. That would be over here. That one is clearly not true. So my answer is B. The best interpretation of the x-intercept is that the diver hits the water at 1.6 seconds. Number 10. The kinetic energy in joules of an object with mass of 9 kilograms traveling at a speed of v meters per second is given by the function k, where k of v equals 9/2 v squared. Before I go any further, I'm going to write down everything that I know about this equation, this function. Okay. So k of v equals 9/2 v squared. So there's an object with a mass of 9 kilograms. Now it's tempting to think, since it's 9 kilograms and we have a 9 here, that 9 represents the mass, but we're not told that. We're not. So don't assume what's not told. What is told is that v, the speed, is v meters per second. Okay, so v here is my speed in meters per second. All right, that I am told. And I'm told that the kinetic energy is given by this function. Okay, so the function is giving me the amount of kinetic energy for this. So if I do this math over here on the right, I will get the kinetic energy. So that means my output is the kinetic energy, the output of that function, because that's all functions are, is input and output. The k of v, the f of x, all that is the output, saying like, okay, when I put whatever's in the parentheses through this equation, what do I get? In this case, I'm getting the kinetic energy. Okay, so which of the following is the best interpretation of, move up here, k of 34 equals 5,202. Now, anytime they say the best interpretation, I try to go through and come up with my own interpretation, and then I see which of the 4 options is closest. I generally do not start with the the multiple choice. Some people prefer it that way. I don't. So I like to get my own idea, and then I find it's clearer and easier to pick out the right one, because often these are very similar. So I want to know what I'm looking for before I go looking. Okay, so K of 34. K of 34. What is in this parentheses? What is it up here? It is V. 34 is my V. And I'm told, what is V? V is the speed in meters per second. Okay, so again, up here, this function up here says, if I plug in a number for V, and V is my speed in meters per second, and I do the math, I am going to get kinetic energy. All right, so with that in mind, I'm looking down at this new one that they've given us, K of 34. So I think this means that if my speed is 34 meters per second, so if my speed is 34 meters per second, then my joules would be equal to 5,202. That I would plug in 34 as my V, my meters per second. I would do the math, and I would get my joules. Okay, so speed 34 meters per second, joules 5,202. Let's look over here at our options. First one says the object traveling at 34 meters per second has a kinetic energy of 5,202 joules. That looks right off the bat like that's the one we want, but let's look at the others because it is the best interpretation. Sometimes they may be close. B, the object traveling at 340 meters per second has a kinetic energy of 5,202 joules. No, there's 340 is not the speed of this. It was 34. B is out. C, the object traveling at 5,202 meters per second has a kinetic energy of 34 joules. I see they're transposing them, and that's not what it said. It said V was the meters per second, and V is that 34. So no, C is not it. And finally, D, the object traveling at 23,409 meters per second has a kinetic energy of 34 joules. No. Confirmed A is our correct answer. It is A. Number 11, the scatter plot shows the relationship between two variables x and y. A line of best fit for the data is also shown. For how many of the 10 data points is the actual y value greater than the y value predicted by the line of best fit? When you have a line of best fit, it is giving you a general prediction, because in this we have these data points, and see they're going around, but they're going in this general upward direction. So the line of best fit is, okay, what line best shows this trend and gives us a little bit of a prediction for future events. Like we can get a good guesstimate for what might happen. Now we don't know what these two variables represent. It doesn't really matter for this, for this problem, but that's what's going on when you have a line of best fit. Okay, so each of these actual data points, we have all these actual data points here, and they're saying for how many of them is the y value of those data points greater than the y value predicted by the line of best fit. That means is which ones, how many of them are above that line. Their y value is greater. So the line of best fit, like for this x value here, the line of best fit predicted it would be here, instead it's here. Its y value is greater. If it were down here, the y value would be less than that predicted by the line of best fit. So let's look over here and see which ones are above the line. So let's count how many of them there are that are above that line that have that greater y value. We've got 1, 2, 3, 4, 5, 6. 6 of them are above the line. The other 4 are beneath. Their y values are lower. So the 6 that are above the line are the ones we want, and that is C. C is 6. Number 12, at a movie theater, there are a total of 350 customers. Okay, 350 customers. Each customer is located in either Theater A, Theater B, or Theater C. If one of these customers is selected at random, the probability of selecting a customer who is located in Theater A is 0.48. All right, and the probability of selecting a customer who is located in Theater B is 0.24. How many customers are located in Theater C? Decimals and percents are the same. They're just written different. So you could also look at this as 48% of the customers are in A and 24% of the customers are in B. So how many are in C? Well, first we have to see what percentage of the whole number of customers are in C. So altogether, this represents all the customers, A, B, and C, or 100% of the customers. So to find out how many are in C, we need to subtract 48 and 24 from 100. You can do that in your calculator. You can add 48 and 24 together and then subtract from 100. There's various ways you can do this. I just kind of do it like that because I'm not a big calculator person unless I have to, because, I just like quickly writing it down instead of risking typing in the wrong number on my calculator, because I do that. I know myself. I know I'll type in the wrong number sometimes. So 72% of the customers are in theaters A and B. So if 100% is the total, I'm going to subtract 72 from 100, and that is 28. So 28% of the customers, or 0.28, are in C. So how many actual customers are in C? Well, now we're having a question that's saying what is 28% of the total number of customers, which was 350. And so for that I would break out my calculator to multiply 350 times 0.28, or 28% of 350. And when you do that math, you will get D, 98. 98 of the customers are in theater C. Number 13, what is the slope of the graph of y equals 1/3 times 29x plus 10 plus 5x in the xy plane? Some people may be tempted to run to Desmos and use that. That's fine. If you want to do that, more power to you. Me, I look at this and I go, if I distribute this, then I might be able to, get this pretty quickly into y equals mx plus b form. And then my m is my slope. So that's how I chose to do it. As with many things, there's more than one way to solve a math problem. You might have thought I was going to say there's more than one way to skin a cat, but I'm not, because that's gross. Why is that a saying? Why did that become a saying? There's more than one way to skin a cat. It's so wrong. Anyway, no, there's more than one way to do a math problem. Not as catchy, I'll grant you, but hey, it's accurate. So here I'm going to distribute 1/3 times 29x. So 1/3 of 29x is 9 2/3 x. And then 1/3 times 10. This really doesn't matter, but it's 3 1/3. It really doesn't matter because the b here doesn't matter, only the m matters, but I'm being accurate here. I'm trying to be accurate for y'all. So I still have that 5x on the end. And now I just need to combine like terms. And so to combine those like terms, again, the 3 1/3 doesn't really matter. But 9 2/3 plus 5x is 14 2/3 x. And that 3 1/3 just comes along for the ride. Now my slope is 14 2/3. Be careful on these student-generated response questions when you have a mixed number like this, 14 2/3. If you are to write in 14 2/3, it will be read as 140 2/3. Even if you try to put a space in there, it doesn't count. You will get it wrong. So to put 14 2/3 in as a user-generated response, it needs to be either 14.66, 14.67, or you can convert it to an improper fraction, which would be 44/3. Any of those three are correct and will be registered as correct by the SAT. Number 14, the length of each edge of a box is 29 inches. All right, I've got a box. And each side is 29 inches. Okay, each side of the box is the shape of a square. Okay, I kind of figured that because they said it's 29 inches all around, but nice of them to confirm it. The box does not have a lid. Okay, so I'm going to draw that so we can see there it doesn't have a lid. What is the exterior surface area in square inches of this box without a lid? Exterior. That is key, because without a lid, you could also start counting the interior, but no. They do not want that. They want just the exterior. Well, how many exterior surfaces do we have? Anytime we're doing a surface area, we need to find all the pieces that make up the outside and add them together. That's like all surface area is that. You figure, what would this look like if it were flat? What are the pieces? And then we add them up. Okay, so here, a normal cube would have 6 sides. 1, 2, and there's a side here, and there's a side on the bottom. 3, 4, 5. And usually there's the side on the top, 6. However, this one doesn't have that lid. It only has 5 sides. All right, so I have 5 sides, and each side is 29 by 29. That is its area. So 29 times 29 for the area of each side, 29 times 29 inches. And then there's 5 of those sides because we don't have a lid, which would have been 6 in a normal cube, but we don't have a lid, so it's only 5. So I just need to multiply those together. 5 times 29 times 29 is 4,205. Yes, I did use a calculator for that one. And that is my answer. Number 15. 5 Eretmacula imbricata, no clue if that's right, a type of sea turtle, each have a nest. The table shows an original data set of the number of eggs that each turtle laid in its nest. And we have this chart, A, B, C, D, E, and the number of eggs, okay? A 6th nest with 121 eggs is added to create a new data set. Which of the following correctly compares the means of the 2 data sets? Okay, so before I look at their options, I know we're talking about means. Mean is another word for average. When we are averaging a data set, we are adding all of the data together and then dividing by the number of data points. So if it was, my data points were 1, 3, 6, and 9, I would be adding those together and then dividing by the number of data points, which is 1, 2, 3, 4. I divide by 4, and that gives me the average or mean of those numbers. They love having questions with mean, median, range, mode. Absolutely add those to your list if any of those to study. If any of those don't sound familiar or you can't say immediately what they mean, absolutely know them. They love asking about all of them. So this one is the mean. Now our first one, we have 5 data points. 149, 144, 148, 136, and 139. And our 6th data point, the 6th nest, is 121. There's 2 ways to look at this. Now, you absolutely can find the mean of the first data set, then find the mean of the second data set, and compare them. But there is a shortcut, and I'll show you that in a minute. So first, the way you would find the mean of the first data set is you would add 149 plus 144 plus 148 plus, that was a weird 8, wasn't it? 148 plus 136 plus 139. And since there are 1, 2, 3, 4, 5 data points, I would divide that by 5. Now, I wrote this down because I added it up earlier. Didn't want to add it right now. That is 716. Divide that by 5, and you get 143.2. So the average of my first data set is 143.2. Now, for the second data set, nothing has changed in those first 5 numbers. Let me move that out of the way. That's for the next problem. There we go. Nothing has changed for those first 5 numbers. The only thing that's changed is we've added another data point, 121, and now we have 6 points. So I'll take that as a little shortcut, that 716 that I had from the previous one, and I'm going to add 121 to it. So that is 837 divided by 6, and I get 139.5. So now I have the means of the 2 data sets. This is data set 1, and this is data set 2. And let's look at our options. The mean of the original data set is greater than the mean of the new data set. That is accurate. I think A might be our answer, but let's look at the others just to be sure. B says the mean of the original data set is less than the mean of the new data set. Nope, that's not true. 143 is not, 0.2 is not less than 139.5. That one's out. C, the means of both data sets are equal. No, that's not true. And D, there is not enough information to compare the means. That's not true either. So A is our answer. Now for the shortcut. The shortcut on this, you don't actually have to do any math. You don't have to type anything in a calculator, nothing. So here's the thing about means. Averages go up and down with new data based on how, if they are higher or lower than the original data points. Now, what does all that mean? Think about it like when you have grades. If you said like you had a couple of tests and you had an 80 and an 85 on your test. Think about in your classes, if you got, on your next test, you got a 70, is your average, your grade, going to go up or down? It's going to go down. Why? Because 70 is lower than any of your previous numbers. Well, what if on, whoa, random ruler out of nowhere. What if on your next test you got a 92? You go, hey, my grade's going to go up. My average is going to go up. Why? Because 92 is higher than any of the previous data points, any of your previous tests. This is always true. So if it was in the middle, it was 80 and 85, and your next test you got an 82, do the math to see how that affects your average. Just a quick little aside to explain what I mean by you have to do the math first here. Let's say I had these four numbers, 80, 82, 85, and 88. To figure out if a new number, like 83, a number that would be in the middle of this range of numbers, of data, to figure out if it would raise or lower the mean, you first have to find the mean of the original numbers. So in this case, I would add all those up, 80 plus 82 plus 85 plus 88, which equals 335. There are four numbers in it, so I divide by 4, and that gives me a mean of 83.75. This is what you're saying is the new number higher or lower than. Since 83 is lower than the original mean of 83.75, it would bring the mean for these four numbers, 5, when we add this one, it'll bring that mean down. If the number that I was adding is greater than this mean of 83, let's say if it was just even a little greater, 84, it's going to take the mean of the data set and bring it up. So that's what I mean by saying you have to do math first. And in the other cases that I'm discussing, if the number that you're adding into the data set is completely outside of this range, if it is below it, it's going to bring everything down. If it's above it, it's going to bring everything up, and you don't have to do that mean first. But if it's in the middle, you would. Okay, back to the SAT problem. In this case, I can tell you from my experience, it's going to go down a little bit, but especially when you get a long string of data points, it's going to be harder to tell. Like say if I had 7 or 8 tests, like in that case, like I said, if I have an 80 and an 81 and an 87 and an 88 and an 81 and 80, and I said 81, So, okay, so I have all these tests that are in the 80s. If I then got a 90, the fact that the 90 is outside of that range, it's bigger than any of them, my average is going to go up, always. If I got a 70, the average is going to go down because it's lower than any in there. If it was in the middle, I would have to do the math. Like if it was an 84, I might go, that's kind of hard to tell with that many numbers. I'm going to have to do the math. So all that being said, let's see what we've got going on over here. We have 149, 144, 148, 136, 139. All are in the 130s or 140s. And the number we're adding is 121. It is lower than every single solitary point. It's going to bring that average down. There's no way around it. If it was in the middle somewhere, if it was a 130 or a 140, and it was greater than 136 and less than 149, do the math. Do the math. Don't guess. It's going to be safest to do the math on that. But here it is very clearly less than any of the original ones. It is going to bring that average down. Likewise, if it had been greater than 149, if the new data point had been, anything greater than 150 or greater, it's going to bring the average up, even by just a little bit. So you wouldn't actually have to do the math. Just recognize it's lower than all the numbers, so it has to bring the mean down, which means, again, A, the mean of the original data set is greater than the mean of the new data set. Number 16. Actually, let me move this over a little bit here. Number 16. In triangle RST, the measure of angle R is 63 degrees. All right, so I'm going to draw a little triangle. It's not to scale. It's just to give me something to draw on. It's like, okay, so I have RST and R is 63 degrees. Which of the following could be the measure in degrees of angle S? Because when we only have one angle, there's no way of knowing what the other two angles are. Impossible. Just it can't be done. But we do know what it could be. Well, what could it be? What is the grand sum of angles inside a triangle? If I add them up, any triangle, what's it going to add up to? It will add up to 180 degrees. So I know if this angle R is 63 degrees, then these two together, what will they add up to? Let's see, 180 degrees, and I subtract 63 degrees. That is going to leave me with 117 degrees. So angle T plus angle S must equal 117 degrees. Look at our choices over here. We've got 180, 126, 118. All three of those are greater than 117. We can't have a negative degree for angle T. So none of those are possible. It cannot be 180. It can't be 126. It can't be 118. The only one it could be, it'd be a very funny looking triangle, but it could work. Angle S could be 116 degrees, and then angle T would be 1 degree. There'd be 1 degree left for angle T. But that is the only one it could be, A, 116 degrees. Number 17. Which expression is equivalent to 8x cubed plus 8 minus x cubed minus 2? This is a somewhat straightforward combining like terms. There's one little wrinkle here that I will point out in a second. When you are combining like terms, we're putting the matching things together, then adding or subtracting. And we say matching, they have to match exactly in terms of the variables that are with those terms. So if I have an x squared and a 2x squared, I can add those together because I have 1x squared and I add 2 more x squareds and I get 3x squareds. But if this was an x squared y, nope, those variables do not match exactly. I cannot combine them. Has to match exactly. Everything has to match. Right, so here we've got some like terms. We have an 8x cubed and an x cubed. We have a number with no variables and we have a number with no variables. So we can combine them, right? Just one little thing we have to be mindful of, and it's this minus. This minus means minus all of this, not just one of those terms. So what I like to do when I have minus in the parentheses, I like to change it to a plus and then change everything inside the parentheses to the opposite. And now, once I've done that, I can get rid of the parentheses and I can just combine like terms very easily. So those two go together, 8x cubed and a negative x cubed, excuse me, or 8 minus 1 would be 7x cubed. And then we have, different color here, we have 8 and 2. So 8 plus 2 is 10. So 7x cubed, there it goes, stylus working now. 7x cubed plus 10, and that is B. But if you notice here, they are really trying to mess you up with that, that minus there and the minus 2. Because if you just treated it as a negative 2 inside the parentheses and you did not take that minus in the middle into account, you would have 8 minus 2 or 6. And look, sure enough, got 2 there with 6. See, they're trying to, I just keep making that ruler appear out of nowhere. They keep trying to mess with you, but the answer there is B, 7x cubed plus 10. Number 18, if 4 times 2x, square root of 2x equals 16, what is the value of 6x? Okay, well, we got a square root here, and we have the x under the square root. Let's solve for x. So I have 4 times the square root of 2x. I want to undo that. So we undo things in order. This x, what happened to it? It was multiplied by 2, then it was square rooted, then it was multiplied by 4. And we're going to undo that in reverse order. It's not going to let me undo what I just did, ironically. Hey, there we go. So if it's being multiplied by 4, I need to do the opposite. I need to divide by 4. And to keep the equation equal, I do that to both sides. So on the left now, I just have square root of 2x. On the right, 16 divided by 4 is 4. Now, I want to undo that square root. So I'm going to do the opposite of a square root, which is squaring. I square both sides, and I get that 2x is equal to 4 squared is 16. So at this point, you have 2 options. We're looking for the value of 6x. Now, you can either solve for x and then multiply it by 6, or if you wanted to say, well, 2x multiplied by 3 would give me 6x, so let me multiply this whole thing by 3 and I'll get my answer. Either way is perfectly fine and accurate and will get you the right answer. But I'm just going to solve for x here. So 2 times x, I want to undo that multiplying by 2, so I'm going to divide both sides by 2. And I'm going to get x on the left and 16 divided by 2, or 8 on the right. And again, they're asking us for 6x. So 6 times my x, which is 8, is equal to 48, which is b. And again, if you wanted to just, at this step right here, say multiply both sides by 3, you would get the same thing. You would get 6x on the left and 48 on the right. Both ways are fine. That's what I love about math. There's often more than one way to do something. Number 19. 2x minus y is greater than 883. For which of the following tables are all the values of x and their corresponding values of y solutions to the given inequality? Okay, so to stop or to limit the number of calculations I have to do, I'm going to look at my answers first and see what things are similar and what things are different. So, okay, so I see when y is 0. For each of these, there's one where y is 0. In all 4 tables here, there's one where y is 0. In the first two, we have when y is 0, x is 440. In the bottom two, we have when y is 0, x is 442. Okay, so if I do this one calculation of 0, if I put 0 in here and see which of these is accurate, then I can eliminate 2 of them. That's what I want. I want to narrow the field in a way that doesn't just take out 1 at a time. It has to take out 2 at a time. That's ideal. All right, so 2x minus y is greater, why I write 2y. It is not letting me undo. It's just pitching a little hissy every time I try to undo a mistake that I wrote. And, I admit it. I miswrite. I make mistakes. I need that undo button. 2x minus y is greater than 883. I am going to plug in a 0 for y. If I put in a 0 right here, I am just going to get 2x is greater than 883. So I'm going to divide both sides by 2. Since 2 times x, I want to undo that. So I divide by 2. And then I get that x is greater than 441.5. So x has to be greater than that. Well, 440, those are not greater than 441.5. A and B are gone. Right now, C and D. For 440, I only want to pick one of these. It looks like they're different. This one says when it's 440, x is 440 and y is negative 2. Here it says 440 and negative 4. And then we have 441 and negative 4, 441 and negative 2. Okay, so they are both, they're both different. Okay, so I'm going to pick one of these points. And see, again, we're starting with 2x minus y is greater than 883. And we'll say, okay, what happens when y is negative 2? I'm going to plug in a negative 2 for y. So 2x minus a negative 2 is 2x plus 2 is greater than 883. Then to get rid of this, to solve for x, I want to subtract 2 from both sides. To undo that, adding 2. Then I get 2x is greater than 881. Then to undo that multiplying by 2, I'm going to divide by 2. And I get x is greater than 440.5. So x is greater than 440.5. This one is not true. That just says 440. Nope, that can't be it. That one is out as well. And D must be my answer. Something else in this particular case, this is just a side note. The method I've just shown you will work for any of these like this. But for this particular problem, something you might have observed is this is a linear function, a linear inequality. Because it's linear, it's a straight line, and it's going to go up or down in a steady and regular pattern. All linear equations are steady and regular. They're not going up and down like that. It's linear, it's straight. Okay. Look at this. It's going 440, 441, 42. 0, -2, -4. Both of those are linear progressions. This going up by 1. This one's going down by 2. What's happening here? 440, 441, 442 goes 0, -4, -2. Wait, what? That's going doot, 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 doot. That's not linear. It's not happening. Y is going up regularly, but X isn't. How about in C? 442, 440, 441. What? 0, -2, -4. This is going in the progression. This is going all over the place. So I would say this isn't linear. This isn't linear. D, 442, 441, 440. It's going down by 1 each time. Here it's going down by 2 each time. That's also linear. So with that, you would have it narrowed down to those two, and then you would only have to compare one of them. You could compare the zeros for both of them. So you'd only have to do one calculation over here with the 2x, etc. So that can save you a little time. Do you have to do it that way? Of course not. You can do it the way I showed you first, where you eliminate 2 of them, and then from the 2 that are remaining, you figure out which one. But I would definitely, whatever you know, with these kind of problems, try to find something where you can eliminate 2. Eliminate half of the answers is the idea. So that you're not like, all right, let me eliminate this one. Let me eliminate this one. Let me eliminate this one. We don't want that. That takes too much time. Again, time is the name of the game. But yeah, that's just a little shortcut that works on this particular problem. It may not work for any of them. The first method I showed you will work for any of them. Number 20, 5y equals 10x plus 11 and -5y equals 5x minus 21. The solution to the given system of equations is x and y. What is the value of 30x? Now, right off the bat, when I'm looking at this, I'm trying to think of, how do I solve this? With systems of equations, we can do substitution, we can do elimination, and we can do graphing. I would not graph this one myself because look at this right here. I am set up for elimination. I don't even have to do anything. I don't have to multiply by anything. They're just going to, if I add these together, it's going to cancel out. So that's what we do when we are eliminating things. We want to add the equations together and have one of the variables cancel out. So they need to be opposites. 5y and -5y, they're already opposites. I don't have to multiply by anything, change anything. I'm good. 5y plus -5y is 0. 10x plus 5x is 15x. And 11 plus a -21 is a -10. Okay, so now I can solve for x. And that's my goal anyway, because I'm trying to get to 30x. So I don't really care what y is. I just need my x. Okay, so to solve for x, I have 15x minus 10. I want to undo what's been done to x. I'm going to add 10 to get rid of that minus 10. I do that to both sides. On the right, I have 15x. On the left, I have 10. Now, x has been multiplied by 15. The opposite of multiplication is division. So I'm going to divide both sides by 15. And I get that x is equal to, and I'm not simplifying at this time, 10/15. Okay, so 10/15 is my x, and I want to know what's the value of 30x. So I'm going to multiply this by 30. And the reason I didn't simplify this is because I know that 15 and goes into 30, so I can do some canceling here. 15 goes into 15 one time, and it goes into 30 two times. Then I have on top 10 times 2, which is 20, and just 1 times 1, or 1 on the bottom. 20 is my answer. And yes, at this point, if you're not comfortable multiplying fractions, you can use your calculator. I like multiplying fractions. I think it's a little quicker because I'm used to it, but you do you. You do what is going to give you the most accurate and fastest answer, which in this case is 20. Number 21, a rectangle is inscribed in a circle such that each vertex of the rectangle lies on the circumference of the circle. Okay, so I'm going to draw a haphazard circle, and I'm drawing my rectangle inscribed in a circle. Okay, ish. The diagonal of the rectangle, okay, I need a diagonal. Let me do that. Okay, is twice the length of the shortest side of the rectangle. Okay. So it's twice the shortest side, so I'm going to call that shortest side x, and it's twice that length, so it is 2x. The area of the rectangle is 1089 times the square root of 3 square units. What is the length of the diameter of the circle? Okay, so the diameter of the circle is going to be this 2x. It is. When the rectangle is inscribed in the circle, its center, any diagonal of that rectangle is going to go through the center of the circle, so that is a diameter. So if I can solve for x, I'll solve my 2x and I'll have my diameter. That's the goal. All right, so what do I have going on with this circle? I've got an x and I have a 2x, and they are testing to see if you remember about 30, 60, 90 triangles. And I'm going to rotate this and kind of draw it. So I'm going to rotate it this way so it comes down like this, because this is usually how they're drawn in your math book. I have x and 2x. That's the triangle here. Now this is a 30, 60, 90 triangle. This is the 30 degrees. This is the 60, and there's my 90. And the pattern is the leg that's next to the 60 is x, the hypotenuse is 2x, and the leg that's next to the adjacent to the 30 degrees is x times the square root of 3. This also is provided to you at the beginning. They give you the 45, 45, 90 and the 30, 60, 90 triangles, the reference. But if you have it in your head already, you don't have to spend the time looking it up. But if you forget it, always remember it is there for you. It is there for you to use. Okay, so x times the square root of 3. So I'm going to write that over here. This side is x times the square root of 3. And we're told the area is this 1089 square root of 3. So what would area be for this triangle? It would be, excuse me, not the triangle, the whole rectangle. The area of the rectangle is going to be length times width. And now I know my length and my width. It is x and x square root of 3. So if I multiply those together, because you can separate this and say it is x times the square root of 3, it makes it a little easier to see. X times x is x squared times the square root of 3. And that's the area. But I also know this is the area. So, come on, go away. There we go. So I'm going to put it right here. So x squared times the square root of 3 is the same as 1089 times the square root of 3. And I'm trying to get to x. So I am going to divide both sides by the square root of 3 to get rid of that. Make it a little easier to look at. So it's 1089 is equal to x squared. Now to solve for x squared, I need to undo that squared. So to undo that, I square root both sides. So I have an x on the left and on the right. Let me check my notes because I forgot what the square root of 1089 is, and I don't know that one off the top of my head. It is 33. There we go. So the square root of 1089 is 33. Now this is where I guarantee some students are going to go 33. I got my answer. Boom. And they're going to move on, and they got it wrong after all this hard work. Ah, how frustrating, because they didn't ask for x. They asked for the diameter of that circle, which is 2x. So 2 times 33, which is 66, and that is your answer. It is 66 units for the diameter of the circle. All right, number 22. Rectangles A, B, C, D, and E, F, G, H are similar. Okay, so similar shapes, not the same as congruent. Congruent would mean if I had two rectangles that were exact copies of each other. They are identical in every way. They can lay directly on top. You can lay one on top of the other, and they're going to line up perfectly. Similar means they are proportional. So it's going to look like I either shrunk or blew up one of these rectangles. So one will be smaller than the other, but you could enlarge this small one to make this big one, and it would then line up perfectly on top of it. So that's what similar is. They are going to be proportional. They'll form ratios that are consistent all the way around. So this side corresponds to this side, then there would be a proportion there, and it would have the same proportion of this side to that side and all the way around. That's what we're talking about when we say similar. Okay, so I have A, B, C, D, and E, F, G, H. The order in which they are given is important. So that A corresponds to E, B to F, etc. Right, back to our our little problem here. They're telling us the length of each side of EFGH is 6 times the length of the corresponding side of ABCD. Get rid of my little highlights here because the undo feature isn't working. Okay, so the length on EFGH, 6 times the length of ABCD, each side corresponding. Okay, so I'm going to call this side up here X, and I'm going to call this side Y. So the corresponding one down here, AB, corresponds to EF, and we're told this is 6 times as long, so this would be 6 times X. And AD corresponds to EH. AD I'm calling Y, so this side is going to be 6 times Y. All right, next part of our problem says the area of ABCD is 54 square units. What is the area in square units of EFGH? Okay, is there any way to know the length up here of AB and AD, what that X and Y is? Is there any way of knowing? No, there is not. There's no way. One side could be 54, the other could be 1, could be 9, could be 6. Could be, it's just 18 times 3. We just don't know. There's no way of knowing. But we do know that I would need to multiply length times width to get the 54, to get the area. So I know that X times Y is equal to 54. Well, what is the area of EFGH in terms of X and Y? Not in numbers yet. We know that EF is 6X and EH is 6Y. So I would need to multiply those together to get the area of this other triangle, 6X times 6Y. I can multiply the 6's together because this is the same as 6 times X times 6 times Y. So I can multiply 6 times 6, gives me 36, and then the X and the Y just come along for the ride. So the area of EFGH is 36 times X times Y. Okay, I'm going to erase this, give us a little more room. All right, so I know X times Y is 54, so I'm going to replace that X times Y with 54. So now my area of EFGH is 36 times 54. And when I multiply those together, I get D, 1,944. And that's my answer. And that's how we can figure out the area of EFGH without knowing the length of either side. All right. Number 23. Which expression is equivalent to 42a over k plus 42ak, where k is greater than 0? The reason they're telling you k is greater than 0 is so you don't get hung up on saying, but what if k is 0? Then this is impossible because I can't divide by 0. So don't worry about that. That's what they're telling you. Don't worry about that possibility. It's fine. It's real. Okay, now if you notice, our answers all are a single fraction. So that's our clue that we need to combine these. We need to add them together. If you need to add two fractions or two things and one of them's a fraction, they must have the same denominator before you can add them. So here I have 42a over k plus 42ak. Now, I cannot add them because this is not a fraction with a denominator of k. It has to be a fraction with a denominator of k in order to add them. So I need to change this 42ak into a fraction with a denominator of k. The way we do that is we put this, say that it's a fraction over 1, because we can do that with anything. We can say it's something over 1, doesn't change it. I need to multiply by k over k, because then I'll have 1 times k on the bottom, and that will get me to that denominator of k. But why can I multiply by k over k? Isn't that changing things? No, because we're told k is greater than 0, so it's not a 0. Any number that is not a 0, if you put it over itself, it's the same as 1. 5 over 5, a million over a million, x over x, those are all just equal to 1. So k over k is 1. If I multiply this by 1, I'm not changing anything. So on the top, 42 and the a stay the same. K times k is k squared. On the bottom, 1 times k is k. Okay, I've converted it. And now I can add them. So that is going to be 42a plus 42ak squared all over k. As soon as we have that common denominator, just like 1/3 plus 1/3 equals 2/3, that denominator stays the same. We just add the top numerators together. Okay, but does this look like any of our answers? No, it doesn't. So right off the bat, what are they trying to lead us towards? The first two look like they're trying to lead us towards combining those in some way. Can we do that? No, we cannot do that because they do not have the same variables. They have to be exactly the same variables for you to be able to add them together. They're not, so you can't. So A and B are not possible. Now C and D, we see they're factoring out. They're taking out that greatest common factor or seeing what's left behind. So in both of them, they're taking out 42a. So if you didn't know what the the greatest common factor would be, they're actually giving it to you because both of them have the same one. So what happens when we pull out 42a? Right, so if I take out 42a from this first term, now remember I have to be able to multiply 42a by something here to get back to there. You can't just say I took out 42a so then nothing's left. Nope, we have to be able to multiply back. There we go, to get the same thing. So what you do in those cases is it's 1 because 42a times 1 equals 42a. Okay, now for the next one, 42ak squared. If I pull out that 42a, what's left is just the k squared. And that is all over k. Now if we look over at their versions, their answers, this one right here is the match. All they've done is they've reversed that so that the exponent comes first because that is the standard way to write it. So 42a times k squared plus 1. And if you want to know the order, the reason you can reorder that, the fancy word, it's the commutative property of addition. Woohoo! Side math fact. And that's all over k. And there we go. There is our answer. It is D. Number 24. Which quadratic equation has no real solutions? There's two ways that you can go about doing this. Whichever one is quicker, whichever one you remember how to do, whichever one works the best for you, that's the way you should use. All right. The first way that you can do it is with Desmos. And the second way that you can do it is by using the discriminant. And whichever one you prefer, that's totally up to you. They both will get you the right answer. And time. Time is the big key. If you can remember to do both of these correctly and accurately, then that's great. Then it just comes down to which is faster. Because we want all the time we can save time, we want to do it. Okay, so Desmos first, you're going to have to type these in one at a time. I wouldn't recommend, typing all of them and just do one and look at it, do the next one, look at it, because if you find your answer early on, you've saved some time. You're going to be looking for a parabola that does not cross the x-axis or touch it in any way. You want it to be up or down somewhere, but it can't be touching it. It just can't. Because that's what the solution is. When you're saying a real solution, it's where it crosses. And that could be just a little touch, or it could be, it could cross it twice. You're looking for the one that doesn't. And that's how you would find that answer. The discriminant comes from the quadratic formula. And that's when you find what are the solutions. And that is negative b. Looks like a weird little negative. My stylus didn't work. There we go. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And for any quadratic, if you plug the a, b, and c, and when we say a, b, and c, we're referring to the constants that are in front of the up to 3 terms. Because we can have a quadratic with just an x squared, and that's fine. We may not have the bx, we may not have the c. We will always have an a. So a is going to be the constant in front of the x squared. B is going to be, if it's there, the one in front of the x. And the c, if it's there, is going to be the one that stands alone. And plugging it into this formula, you will get the answer, the solutions. But if we're just saying how many real solutions are there, all you want to look at is what's under the square root. That is called the discriminant. The reason it determines if there are real solutions, and if so, how many. Imagine if this is, we do the b squared minus 4ac and we get a positive number, square root of 49. Square root of 49 would be 7, and then we're going to have negative b plus or minus 7 over 2a. That's where it would be two solutions. We can have plus 7, minus 7. What if it comes back as 0? Well, the square root of 0 is just 0. So plus 0 minus 0 isn't changing this. There is one solution. And if it is a negative number that comes up, it doesn't matter that it's plus and minus. You can't take the square root of a negative. That is imaginary. So there are no real solutions, only imaginary ones. So b squared minus 4ac is the key, is the discriminant. So all right, now let's look at our four equations up here and see which one is going to have no real solution. I'm going to pull the b's, the b, the a's, and the c's from each of these. Okay, so for a, I'm just going to put them right next to each other. All right, b squared minus 4ac. Remember b, a, c, a, b, c. I don't know why I said them out of order, but you know, that's the order they are in the discriminant. That's why I did it. I had a method. I had a reason. This time I had a reason. All right, so b squared, we have 14 squared minus 4 times a times c. Okay, then we have, I'm going to redo this just a little bit. I'm going to put up here, come on, b squared minus 4ac. Okay, and now I'm going to put my b answer, my b answer, b squared negative 14 squared minus 4 times 1 times 49. Okay, then I have my c, which is negative 14 squared minus 4 times 5 times negative 49. And then last but not least, I wrote this so weird. I just did. Sorry about that. I don't know why I did it that way. We have d down here. Let's make that a little darker. Okay, and so d is going to be negative 14 squared, there's my b squared, minus 4 times 5 times 49. Okay, so first a, 14 squared is 196. Now, 4 times 1 times negative 49. I don't actually have to do this math because I realize when I look at this, 4 times 1 times negative 49 is a negative number. And if I am subtracting a negative number, that's the same as adding a positive. So I have a positive 196 plus another positive number. It doesn't matter what that positive number is. I know it's not going to be less than 0. And I'm looking for the one that's less than 0. So no, A is out right away. When I look over here at C, I see the same thing. I see this negative 14 squared. That's going to be another positive 196. And I've got a negative, and I'm minusing this negative. That's going to be adding another positive number. I don't have to do that math. C is out too. So A is out, and C is out. Actually, just erase them. Get them out of there. Okay, so now I just have B and D left. Well, B, negative 14 squared, is 196. This is going to be a positive number, so I need to multiply it to make sure it's not going to drop this 196 below 0, or make if it will. Either way, 4 times 1 times 49 is 196. So if I subtract 196 from 196, I get 0. D should be our answer, but let's double check it just to be sure. So negative 14 squared is 196. And ooh, got 4 times 5 times 49. Now, if you remember, if you look up here, 4 times 1 times 49 was 196. So this is going to be 980. So 196 minus 980, I don't have to do that math. I can tell that's going to be negative, so D is my answer. Now see, for me, I'm pretty fast personally about doing the discriminant and looking at it and going, oh, I'm subtracting a positive or I'm subtracting a negative, so that's going to be, I can eliminate this one or I can consider that one. I can do that pretty quickly because of the experience that I have doing these sort of problems. Not everyone is like that. So if you are thinking you can do it faster this way, do it that way. If you think it's faster for you to type each of these into Desmos and then see if it doesn't cross or it does, do it that way. You got to know yourself, know your skills, and know what is the best way for you to do these problems. But both ways are absolutely fine. Both will work. Right, number 25. P of t is equal to 260 times 1.04 to the power of 6/4 t. The function p models the population in thousands of a certain city t years after 2003. According to the model, the population is predicted to increase by 4% every n months. What is the value of n? Okay, this is one of those where there's so much verbiage going on, it's easy to get lost in the weeds. So I'm gonna rewrite this, and I'm gonna start labeling things. Okay, so I have 260 times 1.04 to the power of 6/4 t. And we're told that P is the population. Okay. So there's my population. T is how many years. And T is here as well. I've got two places where years shows up. Okay. According to the model, the population is predicted to increase by 4% every n months. What is n? Okay, so to increase something by 4%, what would I have to do? If I were to say, okay, I need to add 4% to something, what do I multiply to do that? If I were just to multiply it, say it's like 100. Oh, come on. There we go, pin. Return to me, pin. All right. Say 100 increased by 4%. Do I just multiply that by 4%? No, I would get 4. That's not telling me what 100 plus another 4% is. It's just telling me what 100 is. No, you have to multiply it by 100% plus 4%. So you're getting that 100% takes care of what you started with, and then it's the additional 4%. So 100% plus 4% is 104%, which I can also write as 1.04. Now look up here, look what's happening. 260 is being multiplied by 1.04. So that's increasing, it's increasing it by 4%. So that's where that is, predicted to increase by 4% every n months. So how would, to increase by 4%, 260 times 1.04, that would do it. That would increase it by 4% if I multiplied 260 by 1.04. But 1.04 is being put to the power of 6/4 t. So how would I solve, how would I know what needs to be there? Well, to increase by 1.04, this would have to be 1. That 6/4 t would have to be equal to 1. So I would just be multiplying 260 by 1.04. It's increased by 4%. So I'm going to take that 6/4 t and set it equal to 1. That's a really weird looking t. Okay, now I'm going to solve for t. To solve for t, I need to get rid of this 6/4. So one of the easiest ways to do it when it's a fraction is just to invert it, make the reciprocal, and multiply both sides by that. So then on the left, you get 24 over 24 t, and 24 over 24 is just the same as 1, so it disappears. And on the right, 1 times 4/6 is 4/6. We can also say that is 2/3. Now we're told t is the number of years. So we don't want t to be a full year, we want it to be 2/3 of a year. Well, how many months are in a year? There are 12 months in a year. So what is 2/3 of 12? It is 8. So in 8 months, this is going to increase by 1.04. And that is my value of n, because that's what they wanted to know. They wanted to know how many months is in, and that is A. 8 is my answer. Number 26. A circle in the xy plane has its center at -1, 1. Okay, I have tried drawing this on a grid, and I wasn't able to do it, so we're just going to kind of imagine the grid. I'm just going to put the numbers that were given. Okay, so its center is at -1, 1. Line T is tangent to this circle at the point 5, -4, which is going to be like over here somewhere. And this point is 5, -4. And this line is, it's tangent to it. Whoa. What happened with that line? All right, let's, can I draw a straight line, please, there? Whiteboard, there we go. That kind of went crazy, didn't it? All right, so that's kind of, it's not the worst line I've ever drawn. It's not perfectly lined up for my purposes here, but that's pretty good. Okay, so when we have a line T that is, come on, T that is tangent to this point, what does it make? What interesting thing does it do? It makes, if you draw a line from the center of the circle to that point, it will make a right angle. Okay, so we have two perpendicular lines. This is going to be a big thing. What are they wanting us to find? What's the last sentence, last question in this problem? Which of the following points also lies on line T? So I need to know the equation of this line. That's how I'm going to do this. So first, what I'm going to do is I'm going to say, what is the slope of this line? Once I know the slope of this line, I can determine the slope of line T because they're perpendicular to each other. So first, how do we find slope? It is change in y over change in x. I'm going to start with the y's of either of these points. I can go in either direction, put them on the top of the fraction, and then put the x's on the bottom. You're going to see it written in your book as like y2 minus y1 over x2 minus x1. So you're taking the y's and then subtracting and putting over the x's and subtracting. The only key is whichever point you start with, you have to start with it on both top and bottom. And what I mean by that is if I start with my -1, 1, I start with that y that is 1, and then I'm going to subtract the other y. Now for the bottom, I need to start with this point again, -1. I cannot start over here with the 5. Nope. I started with the 1 on top, so now I have to do the -1 on the bottom. -1 minus +5. Okay, so 1 minus a -4 is 5, and -1 minus 5 is -6. So the slope of that line that goes from the center to that point is -5/6. Now, to get from one line to the other one that's perpendicular, you're going to take the negative reciprocal, the opposite reciprocal. This one's negative, so my other slope for line T must be positive, 5/6. The reciprocal of that is 6/5. Okay, so now I know that the slope, m is slope in our y equals mx plus b slope-intercept form, because that's what I'm going to use. I know the slope is 6/5. Okay, so now how do I find the equation of this line? And why am I doing this? Why am I doing the equation of the line? The equation of a line, then I can determine which point is on that line. But I need that equation for that line first. Okay, so 6/5, and I'm going to write this over here on the left, y equals mx plus b. And I know that 6/5 is my slope. Now I have my slope in there, I need to solve for b, and then I'll have the equation of the line. And that's important because once I have the equation of the line, then I can determine which of these 4 points is on that line. So to solve for b, I need an x and a y, so that I only have that b variable left. And I know that 5, -4 is on this line, so that is an x and a y value. So I'm going to plug those in. -4 goes in for y, and I have 6/5. My x is 5, and then plus b. Okay, so here, 6/5 times 5, those 5's cancel out, because I'm saying 6 divided by 5, it's another way of saying that, times 5. So those cancel, and that just leaves me 6. So -4 equals 6 plus b. To get rid of, that looks like b plus b, I apologize. Let's write this a little more clearly. 6 plus b, there we go. And so to solve for b, since 6 here is positive, or it's being added, I need to do the opposite. I need to subtract 6 from both sides. And I get that b is equal to -10. Now I know my final equation for that line is y equals 6/5 x minus 10. At this point, you have two options. You can plug in each of your 4 points one by one. If you're very fast at plugging numbers in and multiplying, that may be the best choice for you. The other way you can do it is you take this y equals 6/5 x minus 10, plug that into Desmos, and you drag up and down that line until your x is at each of these positions and see what the y value is. So you drag your stylus along it, your pointer along it, and so like you get to where x is 0 and see is the y 6/5. And you go down and you look for each of those. For me, that's the fastest way. But either way you can do it. I just go whoop, whoop, and I check very quickly. And if you do that, either way that you do it, you will find your answer is C, 10/2 is the point that's on that line. All right, last but certainly not least, we have number 27. I'll be so careful with this one because it's got a lot of verbiage going on. Very easy to get lost in it. For an electric field passing through a flat surface, I'm just going to read the whole thing once and then we'll break it down. Perpendicular to it, the electric flux of the electric field through the surface is the product of the electric field's strength and the area of the surface. A certain flat surface consists of two adjacent squares where the side length in meters of the larger square is 3 times the side length in meter of the smaller square. An electric field with strength 29 volts per meter passes uniformly through this surface, which is perpendicular to the electric field. If the total electric flux of the electric field through the surface is 4,640 volts meters, what is the electric flux in volts meters of the electric field through the larger square? Okay. There's a couple different ways to do this. Okay? There's a shortcut way, and then there is a longer way. I'm going to show you both. All right, so the initial sort of idea is we have this flat surface, we have an electric field is passing through, and it's passing through at a right angle. Okay, and we are given a formula in here. And the formula is right here. It's kind of hidden right there. So it says the electric flux is, that is means the equals, the product means multiply, of the electric field's strength and the area. It so does hate whenever I try to draw a dot. A dot! You tried to draw a dot. I don't know what to do with a dot. I am Microsoft Whiteboard and I stink a lot of the time. Okay, so strength times area. I digress. Flux equals strength times area. All right, so a certain flat surface has two adjacent squares. Okay, so we got one square, and the larger one, the side length in meters of the larger square is 3 times the side length of the smaller. Okay, so I'm going to extend this. I'm going to call this x on both sides, and this one is 3 times, so it's 3x on both sides. Okay, an electric field with a strength of 29 volts, there's my strength, passes uniformly through this, and if the total flux is 4,640, what is the flux that's going through the larger square? Okay, we don't know the area. All right. There's, again, 2 ways to do this. The first one, it's a little bit longer, but it may make more sense to you. The other one is quicker. That one also may make sense to you. We want the one that makes the most sense, where you understand the concept and that you can do, quickly and accurately. So here's both ways. First, when we're told the flux and the strength, but we don't know the area of this whole combined thing, I'm going to solve for the area. So 4,640 equals 29 times the area. So to undo what's been done, I need to divide both sides by 29. And when I divide 4,640 by 29, I get 160. So if A is 160, that's my total area. What's the area of these two parts in terms of x? The smaller one is x times x, or x squared. The biggest one is 3x times 3x. 3 times 3 is 9. X times x is x squared. It's okay. X squared plus 9x squared would be the total area using x. And I also know the total area using numbers is 160. Well, now I can solve for that x squared. X squared plus 9x squared is 10x squared. Then, since x squared is being multiplied by 10, I need to divide both sides by 10. And I get that x squared is equal to 16. Then, to undo that squared, I can take the square root of both sides, and x is equal to 4. And yes, square roots can be positive or negative, but here we're talking about a length, so it's only positive. So then I can go back up here to my sides and go, okay. So this side is 4, and this side is 4, because x is 4. And over here, I have 3x and 3x. This side is 12, 3 times 4. And that side is 12, 3 times 4. All right. So now I go, okay, I want to know the electric flux going through the larger field. Flux is equal to strength times area. I know my strength is 29, and my area is 12 times 12, or 144. And if I multiply those together, I get 4,176, and that is my flux. Okay, that is one way to do it. It is perfectly valid, and that is the right answer, 4,176. But here's something else you can do. We don't actually have to solve. I'm going to say again, x, 3x, 3x. Okay. Once you get to this point right here, we're at 4,640 is the total, the total flux, 4,640. It's equally distributed through this, through these two squares. This one is x squared, and this one is 9x squared. What percentage, proportion of this whole thing is the larger square? The whole thing altogether is 9x squared plus x squared, or 10x squared. And the proportion that's larger square is, it is 9x squared out of that 10x squared. So those x squareds cancel, and we just say it's 9/10 of the whole. So the flux would also be 9/10 of the flux. So 4,640 times 9/10, or 0.9. And that will get you also 4,176. So again, if that made sense to you, that's a nice little shortcut way you can do this. Either way, you're going to get to the correct answer of 4,176. And congratulations, you've completed this section. Hey guys, head over to my new site, mathwithalyssa.com, to get your free 10 video course of SAT tips and tricks. It covers things like how to make a study plan that's perfect for you, how to pace yourself during the test to get maximum points, and so much more. I'm super excited to get this out to you guys, and a lot more SAT prep help is coming for you in the weeks ahead. Again, that is mathwithalyssa.com. And if you liked the video you just watched, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye.